There's probably a surprising amount of plastic in your body right now. At least that's what's suggested by a major 2024 New England Journal of Medicine study, which reported finding microplastics directly inside human artery plaques. But the real concern is that those patients with these contaminated plaques suffered a substantially higher rate of heart attacks, strokes, and death. The implication is that those tiny microplastics in your body could put you at risk for one of those cardiovascular diseases too. The results are not yet conclusive, but there's benefit in knowing how these microplastics could affect your long-term health. To start, I'll explain the study in more detail. In March 2024, the New England Journal of Medicine published an interesting paper by Marfella and colleagues. The researchers reported detecting microplastics and nanoplastics physically embedded inside human atherosclerotic plaque tissue, specifically focusing on carotid atheromas in the neck. The core clinical association was clear. Patients who had detectable plastic polymers in their surgically removed plaques faced a higher risk of a severe cardiovascular event. Over roughly 34 months of follow-up, these specific patients were more likely to suffer a non-fatal heart attack, a non-fatal stroke, or death from any cause compared to patients without detected plastics. Though often confused, microplastics under 5 mm and nanoplastics under 1 micron behave differently, as smaller particles more easily cross biological barriers. It's important to note that the researchers discussed microplastics and nanoplastics, but their primary chemical test measured total polymer mass, not the size of individual plastic particles. They did not manually label each detected chemical fragment as a micro or nano size based on the primary readout. The visual evidence of microscopic particles came from a secondary microscopic analysis on a small subset of the samples. Now, to get this microplastics data from patients, the Marfella study focused on a specific patient population. Researchers tracked adults suffering from asymptomatic high-grade stenosis of the carotid artery, meaning their neck arteries were severely narrowed by built-up plaque. These patients were already scheduled for a carotid endarterectomy, a surgery to physically remove that plaque to prevent a stroke. This clinical setup gave researchers an opportunity to collect raw, human cardiovascular tissue. After the surgery, this prospective observational cohort was tracked for an average of 34 months to capture later cardiovascular events, tracking the composite endpoint of a heart attack, a stroke, or death. However, because it is an observational cohort and not a randomized exposure intervention, it fundamentally lacks the statistical ability to prove that the plastics caused the adverse cardiovascular events. Now, to find plastic inside the excised tissue, here's what the researchers did. They primarily relied on a technique called pyrolysis gas chromatography and mass spectrometry. The laboratory takes the plaque sample and rapidly heats it in an oxygen-free environment. This heat thermalizes and breaks down any complex polymers into smaller signature chemical fragments. The gas chromatography then separates these fragments, and the mass spectrometer identifies and quantifies the specific chemical markers. The final output is a measurement of polymer mass per milligram of plaque tissue. To back up these chemical signals, the team also used stable carbon isotope analysis, looking for the specific carbon signature of synthetic plastics, which differs from biological human tissue. To physically visualize jagged foreign particles embedded inside the plaque macrophages, the researchers also used an imaging technique called electron microscopy, alongside another called energy dispersive X-ray spectroscopy on a smaller subset of plaques. The clever combination of these two techniques allowed the researchers to validate the presence of elements like chlorine to suggest PVC. Out of the 11 common polymers the researchers screened for, 2 primary materials showed up in the data. The first was polyethylene, the most widely produced plastic in the world. Polyethylene was detected in 58.4% of the patient plaques, with a mean concentration of 21.7 micrograms per milligram of plaque. The second plastic was polyvinyl chloride, or PVC, which was detected in 12.1% of the patients at a mean concentration of 5.2 micrograms per milligram. You have to interpret these units carefully. A microgram per milligram is a mass fraction of the analyzed plaque material. It is not a measurement of plastic concentration circulating in the patient's blood, nor does it represent a total full-body burden. Again, remember our nuance about particle size. The spectrometry quantified the raw mass of polyethylene and PVC. The microscopy confirmed that at least some tiny, jagged foreign particles existed in a subset of the tissue, but the primary dataset is driven by total polymer mass. Finding this mass of plastic inside an artery is alarming, but the clinical associations the researchers mapped to this plastic are what truly caught the world's attention. The clinical findings showed a strong association. Patients who had these detectable plastics in their plaques experienced a higher incidence of heart attacks, strokes, and death during the follow-up period. The researchers reported an adjusted hazard ratio of 4.53 with a 95% confidence interval from 2.00 to 10.27. A hazard ratio compares the relative risk of an event occurring over time between two groups, and a score over 1 indicates a higher event rate in the exposed group. Digging into the biology, the researchers found a tissue signal that might explain this phenomenon. The plastic-positive plaques were associated with more inflammatory signaling. Immunoassays and histology showed higher levels of pro-inflammatory cytokines, specifically IL-18, IL-8-1 beta, TNF-alpha, and IL-6. The tissue also showed heavy immune cell infiltration and lower collagen levels, consistent with plaque vulnerability. The working hypothesis is that the physical presence of microplastics correlates with a more inflamed plaque environment and worse subsequent outcomes. But we can't overreach here, as the data shows a correlation and does not establish that the plastics directly cause the inflammation or the clinical events. In fact, independent scientists immediately pointed out several massive blind spots that could explain these alarming numbers without placing all the blame on the polymers. Because this is an observational study, residual confounding is a plausible limitation. The patients with high levels of microplastics might also differ in their environments, occupation, or even intake of ultra-processed foods, factors that independently affect cardiovascular health. Furthermore, this study only looked at patients with severe symptomatic neck artery disease undergoing surgery, meaning we cannot assume these results apply to younger or healthier populations. Critiques also focus on potential laboratory and sampling contamination. Operating rooms and surgical tools heavily rely on sterile plastics. Formal critiques published in the NEJM Correspondence and commentary from cardiologists like John Mandrola noted that without extensive blank samples across collection and analysis, background contamination is difficult to fully exclude. While scientists argue over the exact toxicity inside our arteries, there is zero debate about how these foreign materials are actually entering our bodies in the first place. But how? Public health consensus groups and systematic reviews consistently highlight three primary routes for microplastics to enter the human body. The first route, and the major contributor by total mass, is ingestion. You take in plastics through contaminated food and beverages, especially bottled water and the incidental ingestion of settled indoor dust. Food contact materials drive a substantial amount of physical plastic weight into our diets, which the FDA acknowledges as an ongoing vector of exposure. The second route is inhalation, which can actually be the dominant route if tracked by sheer particle number. You breathe in airborne plastic particles, specifically synthetic microfibers floating in indoor and outdoor air. Airborne synthetic fibers indoors are dense enough that several probabilistic models suggest high daily respiratory exposure, a finding supported by major Science Direct and PMC reviews. The third, and arguably smallest contributor, is dermal contact. While you encounter plastics through skin and personal care products, your intact skin acts as a strong biological barrier, making systemic uptake much lower than ingestion or inhalation. Nonetheless, there are still ways you can reduce the level of microplastics in your body. Let's walk through a few. You might consider swapping to filtered tap water whenever it is safe, and perhaps reducing your reliance on bottled water, which the broader literature often highlights as a notable source of microplastic exposure. Next, it could be helpful to avoid heating your food in plastic containers. Heat can degrade polymers, potentially causing them to shed into your meals, so you might try transitioning to glass, ceramic, or stainless steel for hot foods. You could also think about reducing your intake of heavily packaged, ultra-processed foods to cut out multiple layers of industrial plastic contact, which may also support your baseline cardiometabolic health. To help address the inhalation route, you can look into managing your indoor air. Implementing basic dust control, like using a HEPA vacuum, wet dusting your surfaces, and improving room ventilation is often a good idea. Since indoor synthetic textiles shed fibers, managing dust may make a measurable difference. Finally, you could try to avoid products with intentional microbeads, though keep in mind that dermal absorption is likely a smaller threat. There is no need to overdo it. While we do not yet have human clinical trials proving that these specific changes will lower cardiovascular events, they are generally seen as reasonable steps to potentially lower your exposure if you choose to. We will have to wait for more supporting evidence like rigorous replication studies to confirm indeed that microplastics negatively affect your health. But in the meantime, you can do your best to take control of your exposure today, one microplastic at a time.